Welcome to this demonstration of the signing and verification of signed JSON messages using Ecdsa signatures on a constrained device. Signing of sensed data takes place on the Zolertia RE-Mote, which is based on an ARM Cortex-M3 SoC. In this demonstration, it senses the temperature, builds a JSON message, and then signs it with the Ecdsa signature based on a 192-bit NIST curve. On the software side, the Contiki operating system, together with its network libraries, were used. The microECC library is used for generating the signatures. The signatures get encoded in base64 URL and then embedded in the JSON-based JSON Sensor Signatures format. In this demonstration, we have a client which is connected to another remote, acting as a border router to the wireless sensor network. The border router is connected through the serial line over IP protocol over USB to the client. The sensing remote senses, signs, and provides this resource over its RESTful co-op interface. The client's request then travels through the serial line over the border router to the sensing device, which responds with the appropriate signed temperature message. Now, in case a man-in-the-middle attacker wants to tamper with the message and also the corresponding checksums. With the signatures, the client sees this manipulation and can then drop the altered message and request it again. The client colors messages with valid signatures in green, whereas manipulated messages are indicated with red. To simulate an attacker, the remote firmware image was modified to set the temperature value of every message with an odd measurement ID to 0. As you can see, the client recognizes this manipulation. Wireshark shows us that for every JSON message, actually 3 co-op blocks are exchanged. The orange ones are the requests of the client, and the blue ones are the responses from the remote.
Thank you very much. This was Johannes Bauer. Further thanks goes to University of Passau, to Forth, to University of Bristol, to University of Cambridge, to Zolertia, and to the Rerum project, which builds a framework for reliable, resilient, and secure IoT for smart city applications. Thank you.